Hey, you guys. Welcome to week 5 of distance learning. This week, everything's changing about how the lessons are structured. So you know that in math transitions, we are not allowed to exempt the final exam. It works like dual credit or on-ramps courses where there's a relationship with some college. Our relationship is with UTSA and the Alamo colleges. And that relationship does not allow us to exempt the final exam. So what we've come up with is, instead of giving you one big final at the end of the year, we're going to give you little weekly assessments, and those combined will make up your final exam grade. So this week's assessment will have 8 questions, and each question will be worth a certain number of points out of a total 100. So when we add up all those questions over the next few weeks, it will add up to 100 points. But if you look at today's lesson, for example, look at number 1 right here. And what does it say after the question? The question is, what is the vertex? And what do you see right behind there? It says 2 points, right? So on Friday, when I assign your assessment for the week, this question will also say 2 points. That's 2 points out of 100. 2 points out of all of your little mini final exams added up, okay? So that's the first thing I want to say. That's what that means. The second thing I want to say is we're going into new material today. We're leaving radicals for a little while. A lot of the stuff we're going to talk about today, we have talked about this year. We just need a little review. And all the rest of it, if we haven't talked about it this year yet, you've seen it in other classes. So that's good news. None of it is brand new stuff that you've never seen before. It's all just things that you need to have your memory jogged a little bit. The basic idea of what we're talking about today in this week is quadratics. Remember that a quadratic is something where the highest exponent is a 2. Like if you had 3x squared plus 4x minus 6. That's a quadratic because if you look at the x variables and you find the biggest exponent, or sorry, the biggest exponent on the x variables, it's a 2. So we call that a quadratic. And what we're going to be talking about today about quadratics is 2 things. The first is graphing them, and the other is key features. Key features are just important parts of the graphs. So real quickly, a little bit of vocabulary. Remember that a quadratic graph has the shape of a parabola. It looks like a U. And they can open up like this, or they can open down. And this point where they change direction is called the vertex. If I had the axes, like let's say I had the x and y axis right here, drawn in. Other parts of the graph that we're interested in is, actually let me do that. We're interested in where the graph crosses the x-axis. So this is x, this is y. The graph is the blue thing. The x and y are the axes. So when I say, where does the graph cross the x-axis? It crosses it in 2 places, one here and one here. We call those 2 different, well, we call those several things. We can call them roots. We can call them x-intercept. And sometimes we call them zeros, not heroes. Another point we're interested in is where does the graph cross the y-axis? I'm getting kind of crowded here, sorry about that. But so look again at the blue parabola. Find the y-axis that goes vertically. Where do they intersect? They intersect right here. And we call that point the y-intercept. And so that's some of the basic vocabulary that we're going to be talking about today. We're spending most of this lesson finding those points algebraically, not by just looking at a graph. It'd be easy to just find it from a graph, but we also can do it using our math skills. And so that's what we're going to spend the first part of this lesson doing. So I have this function here, x squared minus 8x plus 12. It's absolutely a quadratic. This form right here is called standard form. There are lots of different, or not lots, there's several. Lots is a strong word. This form right here is standard form, right? ax squared plus bx plus. And the first question is asking us to find the vertex. Well, that's easy if we have a picture, but how do we do that if we don't, when we just have a function? Well, what we want to use is something that you might have to dig back in your memory for, called the vertex formula. The vertex formula says you can find the x value of the vertex by using this little baby formula. X equals negative b over 2a. What does that mean, b and a? Where am I going to get that from? I'm going to get that from the function, the coefficients, right? A is whatever is the coefficient for x squared. So in this specific example, the a is 1, right? When it's not written, we understand that it's 1. And b is whatever's in front of the x value. And in this function, it's negative 8. All right, so a equals 1, b equals negative 8. So we're going to plug those in. But notice that the formula already has a negative that's part of it, okay? You have to leave that there. So this negative I'm writing down is from the formula. But this next negative I'm writing down is from b. They both have to go in there, okay? And then we're going to divide that by 2a, and I know that a is 1. So then we simplify that information. Let me move this over here. There we go. Negative 8 makes a positive 8. And 2 times 1 is 2. And then we simplify that and we get 4. All right. So we know that x equals 4. But this is asking me for the vertex. The vertex is a point. All the points have 2 values. They have an x value and a y value. So I know x is 4 now. So how do I use that information to get y? We just plug it in. Plug x equals 4 into the function. So f of x, and remember that f of x is just another way of writing y, equals x squared, but x I know now is 4, minus 8 times x, now x is 4, plus 12. Now we do this math being careful to follow our order of operations. So you do exponents first. That's the 4 squared. Then the multiplication, 8 times 4. And now all I have left is add and subtract. I do that from left to right. So 16 minus 32 is negative 16. And negative 16 plus 12 is negative 4. Okay, that's my y value. And so the very last step is to write this as an ordered pair. So remember from this step up here, step 1, x equals 4. And then from this step that we just did, we know that y equals -4. And so that's my answer for number 1. And even though number 2 is next is below, I'm actually going to move this way first. So we're going to go do 4 first. Because 2 really should come after 4. I just didn't realize that's how I had everything printed. All right, so number 4 is asking for the roots. Now I talked about when I was drawing this picture up here, how the roots are similar to the x-intercepts or the zeros. It's where the graph crosses the x-axis. There's something I want you to notice on this graph so I'm looking at the 2 highlighted yellow dots up here. Those yellow dots are where the graph crosses the x-axis. But what those 2 dots have in common is that the y value is 0 at both of those places. So we use that information algebraically to figure out the x-intercepts. So my first step over here when I'm trying to find roots is basically you're letting y equal 0, which means you are setting the equation equal to 0. And then, so here's what that looks like. So 0 equals x squared minus 8x plus 12. And you're going to have to solve that by factoring. So we set it equal to 0 and factor. So using our cross method, remember what multiplies to AC and adds to B. So AC is 1 times 12, which is 12, and B is -8. And the 2 numbers that multiply to 12 and get negative and add to -8 are -6 and -2. So we set this up using I'm going to do grouping. If you like a shorter method that gives you the answer correct, you're welcome to do that. So remember what we do with that -6 and that -2 is we're rewriting the middle term, the -8. So x squared stays the same. -8x breaks down into -6x and -2x. Right? It's the same value, it's just written differently. And then the 12 stays the same. And now we group our first 2 terms and our second 2 terms. And we factor out a GCF from those things. So the first group has an x in common. So remember, we don't get rid of that x, we're just factoring it out. We're doing reverse distributive property. And what's left over is x minus 6. And in the second group, because that -2x, that first term is negative, when you divide out the GCF, you want to make sure it is also negative. So they have a -2 in common. So when you factor that out, what do you have left? You have positive x and -6. And now looking at those groups together, we take the x minus 6 out of each of them. And then in that first group, that leaves me with an x, and the second group leaves me with a -2. Right? So now we still are trying to solve for x. So the next thing we do is we take those 2 factors, we set the factors equal to 0 and solve them. So x minus 6 equals 0 gives me x equals 6. And x minus 2, that's my second factor, equals 0, gives me x equals 2. And those are my roots. x equals 6 and 2. So when we're talking about roots, we're not talking about points or ordered pairs. We're just talking about values of x. So x is 6 and 2. And here's why we did this one before we went to number 2. Number 2 says, what are the x-intercepts? When we talk about x-intercepts, we're talking about points. So this needs to be, these are roots. So x-intercepts are roots written as ordered pairs. XY. Well, so we have 2 roots, so we're going to have 2 ordered pairs. The first root, x equals 6, gives me this for an ordered pair. X is 6. Do you remember what y was? How did we even start that problem in number 2? We let what equal 0? The y value, right? So when x is 6, y is 0. And the second root, when x is 2, what ordered pair does that give me? 2, 0. Right? So that's my answers. And now go ahead and read number 5 to yourself. It says, what is the interval where the graph is increasing? Well, let's, and then number 6 goes along, or yeah, number 6 down here goes along with that. What is the interval where the graph is decreasing? So I'm going to talk about both of those at the same time. I'm going to draw a little sketch of this graph. Okay, it's not going to be a perfect thing. We know the vertex is 4, -4. And we know that it's going to open up because the a value of 1 was positive. So this looks something like this. Where this right here is 4, -4. Okay. Here's what it means by increasing and decreasing. And I want you to think of a roller coaster. So you're starting at the left of the graph, okay? You're in this little roller coaster. This is you. Eee, this is your little smiley face. And you're going to go down this roller coaster, right? So if you're following this track, you're going down. And then when you get this bottom point, you start going up. So this right here, this part of the graph is what we call decreasing. The y values are decreasing. X is not decreasing, right? When you go left to right on the graph, X is getting bigger. When we want to know where the graph is increasing or decreasing, we're talking about the y values. What are the y's doing? So here that vertical change is going down. But as soon as you get to the vertex, it starts going up again. The y values do. This is the part of the graph where it's increasing. So that's fine. But it's asking me for the interval where that's happening. That word interval means x values. So what x values make the y values increase? So here's where the graph splits in two. That's the axis of symmetry. All the x values from here over make the graph increase. And we want to write this in interval notation. So at that axis of symmetry, where the graph starts to increase, what does x equal there on the axis of symmetry? It equals 4, right? So that's where it changes directions and starts increasing. This arrow on our graph means it's increasing forever. So starting at x equals 4 and going on forever. So from 4 to forever. That's where the graph is increasing, and we want to write that in interval notation. It's from 4 to infinity and it gets parentheses because nothing's included, right? Those are the x values that make the y values get bigger. And then skipping to number 6, it says, what is the interval for where the graph is decreasing? Well, that's the blue stuff that I wrote on the left-hand side. It's decreasing for all the x values that are on this side of 4. But remember, when you're writing interval notation, you have to write the smaller value on the left and the bigger value on the right. So small on the left, comma, and then big on the right. So the biggest x value for the decreasing side is 4. So we know that's going on the right. What's the smallest value of x? How long is it going out this way? To the left. Because x gets smaller when you go to the left, right? Well, does it ever stop getting smaller? Because if it does, that's the number that I would want to go here. That would be the smallest number, and I would put it on the left. It doesn't ever stop, right? So if it doesn't ever stop and it goes out to the left forever, what do we call that? We call that negative infinity. So from negative infinity to 4, the graph is decreasing. Or you could say from negative infinity to 4, your roller coaster is going down. And from 4 to positive infinity, your roller coaster is going up. All right. So then the last question on this page, so I went from 5 to 6, and now I'm going over here to 3. What is the y-intercept? Well, way back up here at the top of the page where I had all this crowded information. So I'm here again, to the top left. The highlighted blue point where I said that that's where the blue graph intersects the red y-axis. That's your y-intercept. Well, what's true about the x value there at that point? What does x equal? It equals 0, right? So in order to find the y-intercept, you let x equal 0. So earlier in number 4 and 2, when we wanted to know about x-intercepts, we let y equal 0. When we want to know about y-intercepts, we let x equal 0. So y-intercept means that x equals 0. So we are going to literally plug x equals 0 into the function. And here's what I'll get. Y equals 0 squared minus 8 times 0 plus 12. Follow your order of operations. 0 squared is 0. 8 times 0 is 0. Add from left to right, y equals 12. You need to write this as an ordered pair, though. We know that x equals 0 makes y 12. So as a point, that's 0, 12. Now, I just showed you how to do that mathematically, right? The concept behind it and where it comes from. But one really quick, easy way is when you are in standard form, the y-intercept is the constant value at the very end of your function. So notice that we did the math, but in the original problem, what is that constant there? The one that doesn't have an x, it's 12. That's going to be your y-intercept, but only when you're already in standard form. So you can only use that shortcut in this situation. All right, so we are almost done. So let's go to the back. What is the domain and range of this function? So let me give you the picture again. It basically looks like this. Our vertex was 4 negative, oops, that's terrible. 4, negative 4. The domain is all the x values that will work for the function. And for this graph, and for all quadratics, the domain is all real numbers, okay? No matter what x value you pick, there will be a point that corresponds to it on the graph. But that's not true for the range. Remember, the range is your y values, right? So domain is x values. Range is y values. Well, let's look at this graph. Y equals -8 isn't even on this graph. Like y equals negative, so here's where y equals -4. Y equals -8 would be down below that somewhere. So for any y value that's below -4, there's not even a point on the graph. So here's how we would explain that in words. The range is all real numbers greater than or equal to -4. Because those are the only y values that have a point on the graph. Okay. So that is all the questions for that function. Number 8's kind of its own question, its own flavor. This is not standard form. It's still a quadratic because you see it has a squared exponent there. But this is what's called vertex form. And it's really great for figuring out quickly what the vertex is. Now remember, your vertex is xy. Without doing any math at all, we can just look at this equation and figure out what our vertex is. Don't forget about insiders lie. When you see things in parentheses, the x plus 5, you can use this part to find the x for your vertex, but insiders lie. So you need to take the opposite sign. X equals opposite of +5. Okay, so that means our x is going to be -5. And the y value is this one number. That's your y value. And you do not have to take the opposite sign. So my vertex is -5, 4. But read the question again, because that's not actually what it asked me to do. It asked me to graph a basic form for the function. So I'm halfway there, like I have the vertex. But I need to know now, is this graph going to open up or is it going to open down? And here's where I look for that information. I look at the a value, which is right here. This a value, and here's the money question. Is it positive or negative? Positive, right? So if a value is positive, then the graph opens up. If the a value is positive, the graph opens up. So this just asking me to have a basic shape. So I don't need to overthink this. -5, 4 is like, so -5 here somewhere, up 4. So it's somewhere here, and it's opening up. And we're done. I want you to do this next. You have a practice sheet linked in your Google Classroom and an extra practice, okay? I want you to do that in a specific order. I want you to do the practice sheet first. I have it all worked out for you. I don't want you to look at my work until you've done yours. So you do your work, and then check it with my practice sheet. Then you go to the extra practice sheet. If you feel like you need more practice, which I actually highly recommend all of you do, even if you feel super confident, okay? It won't take you, if you're super confident, then the extra practice, it's not gonna take you very long anyway, so just do it. But the extra practice, for those of you who are feeling a little bit less confident, the extra practice is there for you. I don't have it worked out on the extra practice. I have answers only because I want you to try and figure out where your mistake was if you can. If you cannot, you email me. We can email back and forth. We can Zoom. We can send pictures, whatever you need. Okay, we'll figure that out.